Hello students, today we are going to solve a problem from laser and this question asked in CSIR NET 2011. Okay. Okay. And there are basically two parts, part A and part B. Each part contain 5 marks. So there are basically total 10 marks. It's a really interesting question. So you have a 3 level ruby laser. E1, then you have E2 and E3. Okay. So first, this is the 3 level ruby laser, and chromium atom, the density of chromium atom in this ruby laser that is given, that is 1.6 into 10 to the power 19 atoms, 19 atoms per centimeter cube. Okay. So this is basically the energy level diagram of chromium ion, and all the atoms from ground level ion will be excited to E3 by radiation having wavelength 0.4 micrometer. Okay. And these atoms from E3 rapidly come to E2. This will rapidly come. Okay. And the atoms or ions will stay a long time at level E2. And that time is given, lifetime of E2 is given, that is tau equals to 3 millisecond. Okay. And you can imagine 3 millisecond is actually a huge time, right? So we can say E2 is basically metastable state. Okay. Also, they have given the separation between E1 and E2, that is 0.7 micrometer. Okay. Now, in part A, what they have asked? They have asked there is no such radiation exist which can pump the atom from E1 to E2, which can pump E1 to E2. Then the population of level 2, N2 as a function of time, how it will look like. So there are basically options they have given. N2 as a function of time, that is R into tau. That pumping rate, R is what here? Pumping rate from level E1 to E3. So R into tau. Tau is the lifetime of E2 into into exponential t by tau minus 1. Second option that is given, option B, that is n2t, that will be r tau into 1 minus exponential minus t by tau. Okay. Third option that is given, option C, r n2t equals to r t square by tau into 1 minus 1 minus exponential minus t by tau. Okay. And option D they have given, option D is like n2 as a function of time, that is equals to r to t, sorry, r into t. Okay. So we have to find the population of level E2 as a function of type, that is n2t, how it will look like. Okay. So to solve this equation, we will basically use that rate equation. So for rate equation for level 2, what I can write? dn2 by dt. That will be how much? So the increment of population of level 2 is at what rate? That will be basically the rate of pumping. So increment of population of level 2 will be exactly equals to the rate of pumping. And there is also decay from level 2 to level 1. At what rate? That will be lambda into N2. Okay, and lambda is basically what? It is look like same as we have discussed in radioactivity. Lambda is basically what? Lambda is 1 by lifetime of level. Okay, now to find that N2 as a function of time, what I'll do, I'll rearrange this equation. I'll rearrange this equation dN2 by R minus lambda N2 equals to dt. Then I'll integrate it. Okay. So when I'll put time t equals to 0, okay. So obviously dN2 or number of population at level E2 will be 0. At some time t equals to t, there will be some population at level 2. Okay. So if I integrate it, what I'll get? I'll basically get ln natural log of r minus lambda n2, okay, and divide by minus lambda with limit 0 to n2. That should be equals to how much? That should be equals to t. Okay, that should be equals to t. So what I will get from here? I'll get, if I put that limit on this natural log, what I'll get? I'll basically get ln r minus lambda n2. Okay, so this is for upper limit. Now if I substitute that lower limit, I'll get basically get minus natural log of r. Then again I can write ln a minus b, that will be basically ln a by b. So ln a is what? R minus lambda n2, and b will be what? B will be basically r, and that should be equals to how much? Minus lambda t. Okay, so it means r equals to r minus lambda n2 by r. That should be equals to how much? It will be exponential minus lambda t. So it means if I rearrange it, I'll get lambda n2. That should be equals to r into 1 minus exponential minus lambda t. Okay. So it means n2 as a function of time will get r by lambda 1 minus exponential minus lambda t. And we know lambda is nothing but 1 by tau. So if I use it, basically I'll get r into tau into 1 minus exponential minus t by minus t by tau, minus t by tau. Okay. So this is the N2 population of level 2 as a function of time. So correct option will be basically B. Okay. So this is a part A. Now we'll discuss that part B. Okay. In part B, what they have asked, that minimum power is required to achieve zero gain. Okay, so same question, the same setup, everything is there. Now we have to calculate the minimum power required to achieve zero gain. So what does it mean? It means minimum power is required to achieve population inversion simply. And this formula is very famous in Ruby laser. That minimum power is required to achieve zero gain. P minimum, that is how much? That is nothing but total population of chromium ion divided by 2 into H nu p means pumping frequency divided by lifetime of level. Okay, and everything they have given n is given, that is 1.6 into 10 to the power 19. Okay, 10 to the power 19 divided by 2, right? Then h, that is 6.6 into 10 to the power minus 34. And they didn't give pumping frequency, but they have given that pumping wavelength, that is 0.4 micrometer. So I can convert nu to lambda, just like c is speed of light, that will be 3 into 10 to the power 8 divided by lambda they have given, that is 0.4 into 10 to the power minus 6. Okay, from micrometer to meter. And you have lifetime, that is 3 millisecond, it means 3 into 10 to the power minus 3 second. Okay, so this is simple mathematics is there. Just you have to convert nu to lambda. Just nu is equals to c by lambda. So c by lambda is given in the form of micrometer. So I have converted to meter, 0.4 into 10 to the power minus 6 meter, and tau is given, that is 3 millisecond. So I can convert like 3 into 10 to the power minus 3 second. Okay, so if you calculate it, I have calculated, you will get 1.32 kilowatt. Okay, so minimum power required to achieve population inversion or zero gain, that will be how much? 1.32 kilowatt. Okay, thank you.